In this video, we're going to look at using the chain rule to derive a given function. Now, I say a given function, and in this case, you're probably noticing that we have two functions given to us, and it tells us in the question to use the chain rule. So you're kind of thinking, well, how are we going to use the chain rule on one function if we have multiple functions? Well, when we talk about using the chain rule, there are two forms that we can use to take derivatives in this case. We have the Leibniz form, and then we have Newton form. Newton form is going to wait until the next video that we do. What we're going to focus on in this video is the Leibniz form, because the Leibniz form is very helpful in a situation like this, where if we have a function defined by a variable u, that u is used to define another function. When we have something like this, to find the derivative of y with respect to x, the Leibniz form tells us that we can take first the derivative of y with respect to u, and then multiply that times the derivative of u with respect to x. So what that means is we have a function u right here. So in the second part of the product, we're going to take the derivative of this function, this x to the seventh, with respect to x. And in the first function, we have a function described by y, right? Y equals something, and it's defined in terms of u. So in this case, in the first part of the product, we're going to take the derivative of this function with respect to u. That's what this means symbolically, and that's actually what we're going to end up doing. So how we end up writing this is the derivative with respect to u of 3u minus 10 times, as we said before, so we're going to kind of put brackets around this so we know what we're doing, and then we have times the derivative with respect to x of u, which is x to the seventh. So now that we have this written in this form, we got to think about, okay, what does this mean? Well, we're going to take the derivative of this function with respect to u. So any power rule, chain rule, product rule, quotient rule that we use is going to do that to any u term that we have in our function that's inside this parentheses. And in this case, minus 10 is a constant, so when we take the derivative of a constant, it gives us 0. But then we have 3 times u to the 1. So all we're left with in this first derivative is just 3. Because if we use the power rule, we bring that 1 down. 1 minus 1 is 0. U raised to 0 is 1. 3 times 1 is 3. So this is the derivative we get for the first case. And then the second function, we have the derivative of x to the seventh with respect to x. So it's kind of like we're back to normal, taking derivatives with respect to x here. And again, we're going to use the power rule to bring 7 down. X stays the same. 7 minus 1 is 6. So that's our derivative in that second function. And then all we do is we multiply them together. And in this case, we can multiply these constants together to give us 21x to the sixth. So that is a case where the Leibniz form is more helpful than the Newton form. In the next video, we're going to look at what the Newton form looks like and how that's going to be more helpful to us in certain situations.